Hello friends, welcome back. In this tutorial we will study about the properties of exclusive OR and equivalence functions. Exclusive OR is an odd function. It is equal to 1 if input variables have odd number of ones. Now look at here. Here f1 is an exclusive OR function of 4 input variables x, y, z and w. Now suppose x equals to 1, y equals to 0, z equals to 1 and w also equals to 1. Now for this combination of values of input variables, value of f1 will be 1 because input variables have odd number of ones. Here in this combination there are 3 ones. Equivalence function is an even function. It means it is equal to 1 if input variables have an even number of zeros. Now suppose f2 is an equivalence function of 4 input variables x, y, z and w. X equals to 0, y equals to 0, z equals to 1, w equals to 1. Now in this combination of values of input variables, there are even number of zeros. So for this combination of values of input variables, value of f2 will be 1 because f2 is an equivalence function which is an even function. Suppose number of input variables is even, like there are 4 input variables x, y, z and w. Then if input variables have even number of zeros, then number of ones will also be even. Suppose x and y has value 0 and value of z and w is 1. Then in this case number of zeros is even and number of ones is also even. So if there are even number of input variables, right, then for some combination of values of these input variables, the value of equivalence function of those variable is 1. Then for same combination of values of those input variables, the value of exclusive OR function will be 0. For example, here f1 is an exclusive OR function for f1 is an exclusive OR function of 4 input variables and f2 is an equivalence function of same 4 input variables. Then for this combination of values of input variables 1, 0, 1, 1, value of f1 will be 1 because it has odd number of ones. But for this combination of values of input variables, value of f2 will be 0 because it has odd number of zeros. So if the number of input variables is even, then XOR and equivalence functions are complement of each other. Now suppose the number of input variables is odd, right? Like there are 3 input variables x, y and z. So when these input variables have odd number of ones, then number of zeros will be even. Suppose x equals to 0, y equals to 1 and z equals to 0. Here there is odd number of ones and number of zeros is even. So when the value of XOR function is 1 for some combination of values of odd number of input variables, then the value of equivalence function for same combination of values of same variable will be 1. Now look at here. Suppose the value of x is 0, y is 1 and z is 0. Right? Now for this combination of values of x, y and z, the value of exclusive OR function of x, y and z would be 1, because this combination of values of x, y and z has odd number of ones. For the same combination of values of x, y and z, the equivalence function of x, y and z will have value 1 because it has even number of zeros. So it means exclusive OR and equivalence functions are equivalent if the number of input variables is odd. So it means x XOR y XOR z is equal to x equivalence y equivalence z. Now the complement of x XOR y XOR z is equal to x XOR y equivalence z. It is also equal to x equivalence y XOR z. So this function x XOR y equivalence z is the complement of x XOR y XOR z. So the value of this function f is 1 if value of input variables have even number of ones. Now let us design an odd parity generator for 3-bit messages. For odd parity, the parity bit will make odd number of ones in the message. If message has even number of ones, then the parity bit should be equal to 1. Otherwise, parity bit should be equal to 0. Now let P be the parity bit. X, Y and Z denotes the bits of message. Inputs of parity generator should be the bits of message, and output of parity generator is the parity bit. So P, which denotes the parity bit, is the Boolean function of x, y and z. Here x, y and z denotes the bits of message. Now as I told, value of P should be equal to 1 when its input variables, that is x, y and z, has even number of ones. So it means P would be the complement of x XOR y XOR z. It should be the complement of x XOR y XOR z, which is equal to x XOR y equivalence z, and it also equal to x equivalence y XOR z. So P can be defined either of these two Boolean functions. This is the logic diagram which we can draw by using this Boolean function. First one. So this is the parity generator. Now let us design a parity checker for odd parity of 3-bit messages. Now, parity checker is a combinational circuit at receiver side. If it receives even number of ones, right, then the parity checker should give output 1 to indicate error, because we are going to design a parity checker for odd parity. Let's its input variables be x, y, z and p. P is the parity bit and x, y and z denotes the bits of message. Now, if the number of ones in the message is even, then the parity checker should give output 1. Now let the output variable of parity checker is C. Right? Its value would be 1 if the combination of values of x, y, z and p has even number of ones. So it means the Boolean function for the output variable C of parity checker would be the equivalence function of x, y, z and p. So it is the logic diagram for parity checker, which we have drawn by using equivalence gate. Thank you very much.